Good afternoon. Assalamualaikum. Okay, today I will proceed with differentiation. Previously, we had done integration. Okay, where integration is to find area under the curve. Okay, let's say you are given a function from range A to B. Okay, you will need to find the area under the curve. Integration, we have three methods, right? Right, not three methods. What is it? Trapezoid, Simpsons, and rhomboid, correct. Trapezoid, Simpson, and rhomboid. Okay, that one is integration to find area under the curve. Whereby differentiation, this one we had touched. We had touched earlier in Taylor series polynomial. Okay. Okay, differentiation basically it is dy dx, where this one is equal to m of the slope. Right, last time. If you have slope, we want to find the slope, so you will have dy over dx. So you'll get the slope. Okay, and another thing, another symbol that we use for differentiation is f prime x. Okay, so that means single differentiation. If you see f2 prime, 2 times differentiation. Okay, but up to your level for our course, usually the question will ask up to, usually we play around on the single. Okay, sometimes it will ask you to find the double differentiation. Okay, but then that one is using numerical method. Okay. Now remember last time in source of error, in your notes, it include this part, finite series, where this part is actually differentiation topic. So I move this part in chapter 1 to chapter 5, differentiation. Okay. Okay, it's quite simple, differentiation, straightforward, where you have forward, backward, and centered. Okay, let's say you have a curve, then you will need to find the derivative, the differentiation value of this. Okay, let's say this x. In forward finite difference, forward differentiation, forward means what? Move forward, move one step. Okay, so it will move one step ahead. You will need another point over here. So this one will be x plus h. X plus h, okay, the step size. So it will find the differentiation numerically. Okay, so you have these 2 points to find the derivative. Forward, move one step ahead. Okay, so here you see it involves the slope equation, the fx plus h, with this. Okay, this is fx plus h Okay, the fx value. Then here is the fx. Wait, I improvise the curve so that we can see the difference. Wait, Okay, so here is the fx plus h. In other words, fx plus I, fx2. Okay, any letters that you can denote with. Now, this different is the dy. This different is dx. So eventually, it is the slope equation. Forward means move forward one step ahead. If backward, it move backward. Remember, we need the h. So move backward with one step size. Let's say over here, x minus h. So here is the point. So it will connect the fx and the fx minus h to find the derivative. Okay, different with centered. Centered, it involves two points, which is the backward point and also the forward point. Okay, the pink one. Both of these. So you will find the derivative using these 2 points. The pink one. Sorry. Okay. Centered, it involves x minus h and x plus h. Remember, our original point is the x over here. So now it involves 2h. Here is 1h, 1h. So for centered, it involves 2h. That's why you see over here, divide by 2h. Meaning that x plus h minus x minus h. Okay. Okay, so for differentiation, we have forward, backward, and centered. This is the first derivative equation. Any questions so far? Okay. Now, this diagram, similar to my explanation just now, this is the actual point, the x. Okay, so you can see the approximation. This one is centered. We have the x plus h. Here, x minus h. This one is forward. Okay, the approximation between one step ahead. Forward. Okay. Now, last time we had came across this term, OH, right? That one brings the definition of the truncation error with order H, truncation error. So truncation error with order H. Usually it will involve forward and backward. Okay, if centered, it will involve OH2. Okay, why? Because centered involve 2H. Okay. Usually this one will be the first order. OH2 usually the second order. Okay, the term. Now, this is the difference on the arrow just now. For forward and backward, it half the step size, having the step size. So it will half the error. Whereby for centered, it having the step size will quarter the error. Meaning that half the error means 1/2, right? Quarter? 1/4. Which one is smaller? Quarter, right? So when using centered approach, you will see the error is much closer to the true value. The error is smaller. Okay. Okay, we do this example where it asks you to use forward centered. For differentiation, we just play around with that three equation. Forward, backward, centered. This one. Oh. Okay, huh? Previous. Okay. Now we try this example. Usually differentiation, the question will be straightforward. It asks you to use forward and centered to estimate the first derivative. So first derivative means f prime x. If second derivative, double prime. Let me make it bigger. Okay, it already gives you at x 0.5 using step size of h 0.5. Then it asks you to repeat using h 0.25. Okay, it gives you the h already over here. Forward, centered. Forward, it will involve x plus h. Forward, you move one step ahead. If centered, it will involve x minus h and x plus h, right? So you need this data. Okay, I will advise you to do in table form so that it is easier to look. X and fx. X it mentioned at 0.5. Okay, here it means, let's say you have the curve. Something like this one. Okay. X given is 0.5. Okay, here is 0. Now it asks you to find the derivative at this point. Okay, using forward, we need one point ahead. So x plus h is 0.5. 1. Okay, one step ahead will be 1. So you will find this derivative. So here, x 0.5, 1. X minus h, what is the value? 0, right? Okay, then you need to find the fx value for this axis using the given function. Zero. Yes, 1.2. Right? Yes, correct. Okay, these are the fx value. Now remember, this is for h equals to 0.5. H 0.5. Okay, then it asks you to calculate the forward and centered. Okay, forward, we need one step. So fx plus h minus fx over h. Equation of the slope. So it will involve 0.2 minus 0.925. Over h is 0.5. What? 1.45. Negative or positive? Negative 1.45. This is forward. Okay, try for centered, where it involves the x minus h and x plus h. Divide by 2h. Sorry, fx plus h minus fx minus h. Negative 1. Try to find backward. Huh? fx minus fx minus h. If let's say backward, you will need fx minus h. Okay, Tasmia? do you get for backward is negative 0.5. 0.5. Let me know if I go too fast. Huh? Okay, take your time to digest first. You can try to do for H 0.25. What is the true value? Okay. Negative 0.9125. Okay, how to find the true value? You must differentiate the function first. Find the fx, f prime x. Once you differentiate the function, then plug in into your calculator to find the true value. Okay, if you try to find for H 0.25, this is the value. 0.25 for forward, forward, backward. When h equals to 0.25. Is different. Your x and x's will be different as well. Okay, this is the axis for h equals to 0.25. And then the f-axis will be Okay, this is the centered value. Straightforward. Usually this kind of question in final exam, student always gets score. It's a straightforward question. Just plug in the value into the equation. Later we try to do a final exam style question. Okay. Okay, we'll see the difference between the true error when you have H 0.5 and H 0.25. Okay, so the smaller the H, the smaller the error. Okay, if to compare between backward, forward, and centered, centered is much closer to the true value. Okay. Any question? Clear? Now we try this. This function, it asks you to find the gradient. So gradient here means the m. M means f prime x of the graph of y equals to e sine x plus 5x power 2. Okay, so this is the fx. At x equals to 2, step size of 0.5, using forward, backward, and centered. Okay, so you find the axis and the f-axis. X start at 2. Since here it involves backward and centered, you will need x minus h and x plus h. Okay, then find the f-axis. What is the true value? Right. 18.9669. Let me know if you're stuck. It's better to mistake rather than do the analysis. The true value here is the differentiation of the function, not the true value of the function. Okay, you must differentiate the function first. You can straight away plug in into your calculator using the mode DDX. Okay, this one is fx. The true value here is f prime x. Okay, so next we move to, this is the actual chapter 5C slide. Okay, you can refer to the CN. Now, this chapter 5 slide, it again explain in detail of the differentiation. Okay, I will not go through again because basically the same as previous slide. This slide, chapter 5C slide, it explained from the beginning from Taylor series. Okay, where I just go straight away to the equation. Now this one, as what I explained earlier, for forward, okay, backward, and centered. Similar explanation. Okay, now this one, if it has second derivative. Okay, let's say the question asks you to find the second derivative. So you will use this equation. The equation will be given, no worries. Okay, this is the summary of the equation for first derivative and second derivative of forward. Okay, forward. Now, what I want to highlight over here is forward on first derivative. You will see the error will have level OH and level OH2. If the question mentioned, find the first derivative at higher level order. So meaning that you will need to use OH2 level. Okay, you get what I mean? If the question said at higher level order, meaning that you need to use OH2. This one is forward. Similar to backward, okay, up to OH2. Now, centered, as I mentioned earlier, it starts with OH2 because it used 2H. Okay, it quarter the step size for centered. That's why it used OH2, higher level order. And that is why also when you calculate the value for centered, it is much closer to the true value, right? Then the higher level order for centered will go up to OH4. Okay, all these equations will be given in the appendix. Okay, now let's try some example. This one you can try on your own. Huh? Now I want you to try. Oh, sorry, I haven't erased this one. Okay, this one from the textbook example, it asks you to find, let me make it bigger. Just ignore the ink. Huh? It asks you to find forward, backward, OH, and center of OH2. Okay, this is first level, both for forward, backward, and centered. For the first, to estimate the first derivative, this is the function given. Similar approach as we did just now, find the axis and the f-axis. Okay. Then from there, plug in into the equation, you will get the value over here for forward. Okay, find the value axis and f-axis. Then plug in the value into forward, backward, and centered. Okay. I wanted you to try this one. Yeah. This is test May 2019. Wait, let me erase first so that you don't confuse. Okay, here it gives you this function. Find the derivative of given function by using forward and centered. This one, it doesn't mention first or second. So if it doesn't mention, assume first derivative. Okay, find first derivative. Means the f prime. Okay, first derivative, f prime. H is given as 0.5, x equals to 3. Okay, now you see, for A, forward at level accuracy of OH2. Forward. Now forward, it involves plus H or minus H. Plus H. This is the equation given, and this equation is not labeled. You should know which belongs to which. Okay, forward. First derivative, we find only f prime x. Okay, this refers to forward, but at level H. Now this f prime, higher level, plus h. You see plus, plus sign. So this one is forward at OH4, level 4. This is the equation that we need to use for A. Correct? Sorry, here is OH2, sorry, not OH4. Sorry, this is OH2, not OH4. Centered, we need OH4. Okay, B, we need centered at OH4. Now find F prime X. Centered, it involves minus and plus. Okay, both. This is minus, minus. This is backward. Plus, minus. This is centered, but OH2, first level. Okay, this involves plus and minus. Centered at OH4. This is the one that we need. Okay, so identify the equation, then you identify the data involved. From the equation, you need xi plus 2 and xi minus 2. For centered, for forward, you need fxi plus 2, up to plus 2. Okay, so then develop your data. X is 3, sorry. X is 3. This is your starting point. X equals to 3. From there, xi minus 1 means minus the h. H just now is 0.5. Okay, then xi minus 2 minus again 0.5. Okay, it's something like this. This is your x. So you need xi minus 1, xi minus 2. You need 2 points. 2 points backward. Then you need 2 points forward. Okay. Each of the point having the same step size, which is the h. The what? Equation, wait. This one, the forward. Oh, okay. Oh, sorry. Function. The main function. How to know your answer is correct? Find that value. Okay. I can see all of you can get. Rabia, are you okay? If you get the value approaching the true value, which is 29.0855. Okay, so if the value that you calculated approaching the true value, meaning that you are on the correct path. Okay. Now, I want to share with you the question for test September 2019. Okay. I apologize for the ink. I forgot to delete. Now I want to discuss only because we are running out of time. Just to identify what are the values that you need to find. Okay, here the question asks you to approximate the f prime 1.2 using second derivative. So here it is f double prime x. What is your x over here? 1.2. Sorry, not equal 1.2. X is 1.2. Now, this question already gives you the data, the axis and f-axis. You will need to identify which data that you require for the equation. Okay, here is your x, 1.2. There's your x. Now, it asks you to find for forward, backward, and centered. Second derivative. So, second derivative, we look for f double prime equation. O level H2. Okay, so these are the equation involved. This one is for forward. Okay, for forward. Backward. How to know it is backward? It involves minus only. Okay, then centered. Okay. Double prime, second derivative. So the infos that you required, fxi plus 1, fxi plus 2, fxi plus 3. So you will need to identify the value. From the given data over here, identify your value. This is your x, starting point. So moving backward, -1, -2, -3. Moving forward will be +1, +2, xi plus 3. Okay, so this is the axis. And it already give you the f-axis. You just plug in into the equation. Okay, then you will get the value. These are the answers. Okay, you can try at your own time. This one later. Next, I want to share with you final exam. This one is final exam May 2021. The method is similar. It's just the function different. In final exam, the function will be a bit complicated compared to exercise and test. So here you see the function, it involves a bit complicated function. At x 0.5 pi with step size given as 0.03, okay, m 0.03. It asks you to find the backward and centered. Okay, this question, it doesn't mention whether OHO or OH2. If it doesn't mention, you can choose any level. Okay, because it doesn't mention, so you can choose any level. But gradient here means f prime, f single prime. Okay, yeah. Okay, so that's all for differentiation. Just know what are the data to be input into which equation. Any question? Clear? Easy? Try to do the final exam question. I think I have uploaded in CN, right? So you can try. Now we are done with 5C differentiation. Left one more, which is the ODE. Tomorrow I will start ODE. ODE will take some time also only. So if we can finish tomorrow, next week no more class. Only left with the test. Okay? Okay, that's all. Thank you.